video, I'd like to give you some review of solving equations and inequalities. All right. So an equation has two expressions on each side of the equal sign, and there's a certain set of values for the variables in the equation in one or both expressions that will satisfy the equation. That means it'll make both expressions on either side be equal to each other. So let me give you an example. So if I had like x plus 4 is equal to 2x minus 3. So on both sides we've got an expression involving a mystery number denoted by the variable x. So to simplify the equation, that's one technique to solve an equation, is by rewriting it so that it looks like something where the answer is obvious. Alright, so we can subtract, add, multiply, divide both sides by the same quantity. So whatever this variable x is, let's subtract it from both sides. And let's also add 3 to both sides. And then let's see what we have left over. So on the left side, we will have a 7 left over. On the right side, we'll have a single x left over. Now, after making those adjustments, it should be pretty clear that the value of the mystery variable that satisfies both sides is 7. In fact, if you plug it in, if you replace the x in the first equation with 7, you'll see that both sides are indeed 11. Okay, so that's one technique to solve equations, is do the same thing to both sides. Okay, you could pretty much, you can multiply, add, subtract, and multiply by any quantity you like. The only danger is with division, you have to be careful not to divide by 0. So keep that in mind. All right. Now, sometimes in addition to adding, subtracting, multiplying, or dividing both sides by something, you want to tweak one side in a different way. Let me give you an example of something called distribution. So let me erase this. All right, so imagine that I had something like 4 times x plus 3 on one side of an equation. So I can rewrite this. This is equal to 4x plus 12. And hopefully you remember that what you do is you take that number, that quantity, that expression on the outside, and you simply multiply by everything inside. So 4 times the first blob there, the x, and then 4 times 3. So you end up with the product 4 times x and then 4 times 3, which gives 12. Alright, so that is distribution. And you can have more complicated distributions, like maybe you have 50x times y on the outside, and maybe on the inside you have the product AB plus CD. Okay, still same idea. You still take the blob on the outside and multiply it by each of the blobs being added or subtracted on the inside the parenthesis. So that whole mess is still a similar idea. So you would get 50xy AB. And let's say, just to make it different, let's say that I had subtracted inside, had a difference this time. So now on the second blob I'd have minus the product 50xy times CD. Alright, so that's all well and good. Now sometimes you'll have two parentheses bumping up against each other. So let's discuss that. So what if I had something like x plus 4 multiplied by y minus 1. Okay, and I could not only have 2, I could have 3 parentheses, or 4 or more all multiplied together. So how in the world do we distribute? Do we kind of expand, use your favorite word, change the appearance of this red one? Okay, now the general trick is, it's going to be similar to what I said before about taking what's on the outside and multiplying it by the, okay, except this time the x plus 4, we've got 2 guys to multiply. Okay, so I'm going to take the x and multiply that by everything in the second parenthesis. All right, see that? And then that 4, I'm going to take the 4 and multiply it by everything. So it's real. Can you see that the red example is really two versions of the first of the black? Yeah, the first black example. Okay, if you could remember that, then you're good to go. And then so you can do each of these two examples, and you'll be happy. Okay, now if I had 3, 4, 5 parentheses, it would be the same way. I'd have x. Let's say the first parenthesis was x plus 4. So x times all the rest, however many parentheses there are, and then plus 4 times, and again, however many parentheses there are, and then I do each of those separately. Okay, so this will always work. Now, because we always, or not always, but we often have a situation where we have two parentheses like this, you could memorize. I did it in 2 steps. You see how I had equal an expression, then I had a second expression. You can memorize a trick to do it in one line. Okay, some people refer to it as FOIL. I'll show you what that stands for. FOIL, where the F stands for the pair of the first guys, then the outer, the inner, and the lasts. Let me show you what I mean by that. So what's the first blob in each parenthesis? Well, the first parenthesis had an X, okay, and then the second parenthesis, the first guy, was a Y, so those are the firsts. Okay, and then clearly the 4 and the -1 are the lasts within. So notice that the XY is a product of the firsts. Okay, so that's how you get the F in FOIL. Notice that the -4 is a product of the lasts. That's how you get the last in FOIL. Okay, and now the outer and inner. Okay, the outer is, you want to look at the guy on the extreme left and the guy on the extreme right. So the X and the -1. Sorry, so you have an extreme right O and an extreme left O. Okay, notice that this -X right here is the product of those two outers. All right, and then the inners are the leftover guys, the guys that are not on the extreme right or left. So that's the 4 and the Y. Okay, and notice that this 4Y right here is a product of those guys. Okay, if you want to memorize that, you can save yourself a step and do it in one shot. All right, just a little helpful trick. That's called FOIL. Now notice in the second black example that I had more than one variable. So the rules of algebra don't change just because you have more than one letter, more than one variable. You still shuffle things around, distribute, do everything the same as you did with one variable. Okay, so don't be intimidated or confused if you see an X and a Y or even more variables. Okay, now let me talk about solving inequalities. So what if I told you that I had a mystery number, maybe plus 10, and that was less than or equal to 7 minus x? All right. So first, the good news. Solving inequalities is a lot like solving equations, like I was just talking about. All right. So in fact, you can a lot of times do exactly the same thing. So if this was an equal, let's just pretend that the less than or equal was really an equal sign. So I would maybe add x to both sides, maybe subtract 10 from both sides. So then I'd get 2x is less than or equal to -3. All right, then I might divide both sides by 2. So x is less than, so look at that. Okay, so the solution to the inequality I started with, there's several, in fact there's an infinite number of values that'll satisfy that inequality. It's all the numbers. You can replace x with any number that's less than or equal to -3/2. Okay, and you saw that I was able to solve this inequality just as if it was an equation. All right, there is one twist. There is one situation where it's not the same as solving an equation. Let me show you that now. Okay, now suppose instead I had something like minus x plus 5 is greater than 10. Okay, so I subtract 5 from both sides, so minus x is greater than 5. Now I multiply both sides by minus 1, so x is greater than minus 5. For example, let's say 0. 0 is bigger than minus 5, right? Plug 0 into the very beginning red equation. You will see that it's not doesn't satisfy it. Okay, so minus 0 plus 5 is not bigger than 10. So something went wrong. Okay, what went wrong was this here at the very end. Whenever you multiply or divide by a negative number, you need to swap you need to change the inequality sign. Okay, so when I multiplied by minus 1, what I needed to do was, so the minus x becomes an x, the 5 becomes a minus 5. That was fine, but now instead of a greater than symbol, I have to make it a less than symbol. You see that? Now, pick any number that's less than minus 5, and you'll see that that will satisfy the original red equation. Okay, so keep that in mind. Whenever you multiply or divide by a negative, you need to switch from a greater than or a less than, from a less than or equal to a greater than or equal.